Hi, I'm Michael Pfeifer from Industrial Metallurgists. I'd like to talk to you about my perspective for how I see products. Basically, I see products as being an assembly of materials that have been shaped, formed, manipulated, and modified into different shapes, and those different shapes are brought together to make a product. And when making these different shapes, there are two things that can be engineered, and I'll be talking about that. But this concept applies to all products: toys, bicycles, kitchen appliances, medical devices, hand tools, and also structures like buildings and bridges. Any product is an assembly of different materials that have been shaped and manipulated and modified to form different components. Those components are brought together to make the product. So here's an example. Look at this bicycle and look at the crankshaft or crank assembly of the bicycle. And you can see that the crank assembly is composed of different components. Each component has been made of different materials that have been manipulated and shaped and hopefully engineered to form the different components. And also the shape of the components has also been engineered. And then those components are brought together to make the bicycle. So for any component, its performance, reliability, and cost depends on two things. And both of these things can be engineered: the component form and the materials in the component. Now, I'm a metallurgist, so I'll focus on metals, but the concepts also apply to polymers and ceramics and other new materials. So looking at form, we have the things that can be engineered are its shape, its the component shape, component dimensions, and features. And thinking about the metals, we can select different alloys, different fabrication methods that will influence the component properties. Also, heat treating, coating, and other aspects of the metals can be engineered. So by engineering both the form and the metals used in components, we can optimize component performance, reliability, and cost. Now, the problem I see out there is that many people, many design engineers, focus on engineering component form and don't look too much to engineering the materials in order to find ways to optimize performance, reliability, and cost. And that can put people at a disadvantage because by engineering both, we can then find trade-offs in order to optimize performance, reliability, and cost. So here's a quick example. This shows a bolt, and there's two different applications of the bolt. One is to hold down a table in a cafeteria, and the other is bolt used in bridge. Now, for the different applications, there are different performance requirements, that it's the strength that it has to be able to support, also reliability, different reliability requirements, maybe corrosion or fatigue, and then also different cost requirements. For the table, it doesn't have as high of strength requirements. Also, it's not going to be exposed to corrosive conditions. So we can use perhaps a lower strength steel and have a smaller bolt. Whereas for the bridge, we'll need a larger bolt and a higher strength steel that probably has to be heat treated, and it may even be made of a material that has corrosion resistance or has a coating on it for corrosion resistance for the bridge. So these are two different applications where both the form and materials can be engineered in order to optimize performance and reliability and cost for that particular application. And this can be done for all components. And from my perspective, what I try to do when I'm designing a component is to focus on engineering both form and materials. And when we're thinking about materials, not just the materials from the performance and reliability perspective, but also what materials are easy to use to fabricate the component. I want to select a material that's easy to fabricate rather than a material that's a hassle to fabricate a component out of that. And that's one way of optimizing cost. So that's my perspective on products. It's an assembly of materials that have been shaped and modified and manipulated and engineered to form components that are brought together to form a product. And I think that if you start seeing products as being that can put materials in a whole different light and cause you to perhaps design components and products in a different way. Interested in learning more? We offer metallurgy courses, live virtual short courses, videos, articles, podcasts, and also corporate training. Just go to our website. It's at www.imetllc.com, and you see all our different services, the different training we offer, and also the free articles and podcasts that we have. If you want to get emails about our articles and podcasts and webinars and courses, sign up. Just give us your email and your first name, and we'll add you to our mailing list, and you'll get emails about those things. Thanks for watching. Bye.